Hi everyone, my name is Varsha and welcome to Study with Varsha. So in today's world, every company is is moving toward microservices, and Kubernetes has become the standard of container orchestrations. But managing Kubernetes cluster is not that much easy, and that's why where AWS EKS comes into the picture. So in this session, we will do a complete deep dive into EKS, and today is the day 2 of EKS. So without wasting the time, let's start. Okay, so one second. Yeah. So if we are talking about real-time example, suppose like imagine or suppose whatever you want to do, you are running a banking application with 20 microservices like login, funds transfer, loan processing, notification, etc. So instead of manually managing Kubernetes on EC2, you can use EKS. So there AWS ensures the control plane is always available and scalable. So that thing yesterday only we discussed. So first plus what we have discussed, what is Kubernetes, AWS responsibilities, that thing we already have discussed in yesterday's class. So what's new? See, architecture we also already discussed that control plane, what is the worker node, networking, real-time example, and that deployment mode that is already like self-managed or managed node group, AWS Fargate, like that is serverless, real-time that we discussed. Networking part like networking security store. So in networking, I today we will discuss in a very detailed way. See, that is networking. So yesterday we didn't discussed in that much detail way. So in networking itself, one thing is there that is pod networking. That is nothing but VPC CNI. Okay. So here each pod get a private IP and that will communicate field native to the VPC. And one is services. Second will be services. In that networking, there will be a cluster IP. Cluster IP, you all know that will use for services may internal use that we discussed in last class also, and one will be node port that will expose our application within a certain port range that is 30,000 to 32,677, and one load balancer so that will integrate with application load balance or ALB or LB. Now that services we discussed all three in services like if you will talk about mm, cluster IP, uh, that one second one was node port and that load balancer that we discussed. Now, one thing is there ingress. So what is this and how it works? So that ingress is nothing but it route traffic to multiple services via single load balancer. So in real time, we use ingress like many if someone is working in MNC, they can understand because sometimes customer will say like ingress, egress IP, some changes we have to do. So that is only ingress. Network policies we have in that uh, network policies. So what is network policies? Which control pod can talk to each other. Okay, with the help of network policies. Sorry, P policies. Now, if you are talking about real-time example, so in a banking application, if you know that SBI or anyone, customer data service would not be accessible directly by notification services. So network policies can enforce and such isolation with the help of network policy. We can do. If that security part we didn't discuss in that much detailed way last class, so today we'll discuss. So in security, what is that? First thing is that IAM plus RBAC. Okay, so this integration is there, so that like IAM is identity access management, so that map rules to the Kubernetes user. Okay, and even IAM roles will be there. That for service account. In short, if we'll talk, then 1 second. So yeah, we are talking about that IAM role for service account. That in short, we can say IAM roles. So R for service account. So here, what will happen? We can assign that IAM role to the public pods. And now in security only we are talking, that is encryption, secret encryption. Sorry, secret encryption. ENCRY. So in that, secret encryption means that if some sensitive data will be there, like password, API keys. So with AWS KMS, we can encrypt. Now, pod security. Pod security. So here we can restrict root user access in the pod. And if we're talking about a real-time example, for this also we can take so that we can easily understand. In an insurance application, uh, the claim service pod might need access to an S3 bucket with policy document. But using IRSC, you can give access only to that pod instead of entire node. That understand. Now, storage we didn't discuss yesterday in a detailed way. So for storage purpose in EKS, what we will do, Amazon EBS CSI driver one. Amazon EBS CSI driver. So here that will store in a block storage, good for the database. And one will be there like Amazon EFS CSI driver that will shared storage, where good for multiple storage. We can use when multiple availability zones will be there. Access FX CSI drivers will be there. And if you're talking like how can I explain? Suppose one banking transaction logs will be there. So that will store an EBS attached to a DB parts, and user profile picture in a social media application that will store an EFS. So multiple pods can access them simultaneously. Now, EKS scaling. Scaling, we know that yesterday we discussed scaling, but how? What? So in that, one will be there that will horizontal pod autoscaler HPA. There, that will scale pods based on the CPU and memory use. And one will be like CA, we can say that is cluster autoscaler. So that scales worker node when pod can't fit. And one will be like carpenter, that is modern autoscaler, that will be faster, cost efficient, and scaling. If you're talking about a real time example, so during IPL cricket live streaming, users traffic spikes up to like lakhs or 1 millions. So that time horizontal pod auto scalers adds more pod to handle the traffic, and CA added EC2 nodes to automatically. So that is EKS scaling. Now we can discuss monitoring and logging. Okay. So for monitoring and logging, what we do and logging. So for that, what we do? So CloudWatch we use for logs and metrics. Prometheus and Grafana we use for custom monitoring and dashboard. Open telemetry we use standardized telemetry data collection. And real-time example, if you're talking, see, if a food delivery application is there, so if order services latency increases above 2 seconds, so CloudWatch alarm can alert DevOps team. Now cost optimization, if you are using any services, so cost optimization, that is most important. So here you can use spot instances in a node group for non-critical workloads. You can use Fargate for rusty or unpredictable workloads. You can scale down at night or weekends, and you can scale like if you're talking suppose In an education platform like Byju's or some, so peak traffic is during the daytime or evening time. At the night, that will scales down to the cluster to save the cost. Now, if we'll talking about what is the best in EKS, that will be multiple availability zones for deployments. You can use infrastructure as a code with a Terraform or cloud formation. We have a proper IAM and RBAC concepts. You can enable cluster loggings, and use cases means it will support microservices like banking, e-commerce, machine learning also. CI/CD pipeline is also there. Hybrid clouds will be also there. And suppose EKS is there and ECS is there. So in ECS, AWS that is native, simpler hai. But EKS will be Kubernetes native. So that will portable cloud like across clouds. And EKS that is no control plane over it. And if we're talking about self-managed, that is fully control. So, for example, suppose a startup may start with ECS, but like simple and AWS. Later, when extending to multiple cloud, they can move to EKS. Now, if I will say, uh, at last, I just want to say about EKS that tomorrow's class I'll discuss